just get my technology set up, let's just have a quick survey. People who know what source control is, hands up. Keep your hands up if you know what Git is. Keep your hands up if you know what rebasing is. Perfect. Keep your hands up if you know what it is and actually know what it does. Oh, right, okay. So I'm going to start it off with something just to kind of give the people that didn't put their hands up at the start. Oh, long way around. You don't want my speaker notes, trust me. So I just want to start off, kind of get everybody up on the same level. Let's just talk a little bit about what source control is, what version control is. Apologies if I say source control, I actually mean version control, same thing, but sometimes I say source control. So what I kind of want to go through today is these four things. I want to talk about what version control is. I want to talk about why we need it. So that's going to be kind of what the base level is, why we should all have it, but also the additional benefits it gives us. And then I'm going to talk a little bit about what Git is and how Git differs from some of the other source controls. And I'm also going to talk about, if we have time at the end, because this is meant to be a lightning talk, I'm just going to do a little bit of commands at the end. So what is version control? It's a time machine. That's the basic idea. The idea of version control is that you can go back in time and you can see what life was like, what your development life was like a while ago. Now, everybody's seen and used this if you have a Mac. Apple's time machine is exactly the same idea. The idea is that as your files change, as you work on them, a backup is taken and stored elsewhere, and you can go back and you can look at how things were a while ago. That's kind of the base level. That's what you get for free using a backup system. So the question is, what does version control give you over and above a backup? And the answer to that is things like the who, what, and why of those changes. So it's not just about this thing changed, this is what it was like a week ago. It's this is how it changed. This is the change that was made. This is who made the change, and this is why they made the change. That's kind of what version control is. When you're using Apple Time Machine, you can easily go back and you can restore your files a week ago, but you don't know why they changed, you don't know who changed them, and you don't know what the exact changes were. So that's what Git does. It gives you the who, the what, and the why. So this is a command I'm going to show you later that shows you that history, and it says who made the change, when they made it, and the message. So that's kind of the message of version control. You can also do experiments. So backups are just a linear history in time. They tell you, okay, this is what it was a week ago, but they don't allow you to say, I'm gonna have an experiment. I'm gonna try something and see what happens. With version control systems, source control systems specifically, you can do things like experiments where you can take what you're working on and you can say, right, I'm gonna branch this off, and this is what they're called branches. I'm going to say, I'm going to take the current state in time, and I'm going to go, right, let's try something. Let's see what happens. I'm going to try adding wasabi onto my toast. Bad idea. Or we could say, I'm going to try adding soy sauce onto my toast. Slightly better idea. But of course, as you're doing these experiments, you don't really know what's going on, so we probably want to give them names. I remembered it the right way around. I wasn't sure if I was going to remember that the right way around. And of course, once you've decided which experiments you like and which experiments you don't like, you can bring them back into the main history. So this is kind of the benefit that version control gives you over and above backups. It's not just this single linear history through time. It's also the ability to branch off and try things and come back again and try things and come back again. So now that we all kind of get what source control is, what version control is, I did it again, let's talk about what Git is and how Git differs from this kind of slightly old style of doing version control. So the way version control used to be done, this is the days of Subversion and CVS if you were developing 20 years ago, is there used to be a single kind of source of truth. There used to be, okay, this is where we are. This is, everybody's talking to the same place, but this doesn't scale. You ended up with scenarios where you'd have developers spread all around the world, you'd have people working on the same files at the same time, and it was just a mess. And For people that don't know the history of Git, Git was created by the same guy that created Linux. And you can imagine something like Linux, you've got hundreds of developers spread all around the world. And the kind of interconnections and the way they were working together just wasn't really working right with their chosen source control subversion. So Linus invented Git to solve those problems, to solve the issues of having hundreds of developers spread all around the world. And he solved that by, instead of having a single source of truth, having multiple sources of truth, having multiple locations. So every developer on their laptop had this backup. Every developer on their laptop had this history, this time machine going back in time. Rather than having, if you imagine the time capsule, the Apple time capsule, rather than having that in one place and all the backups going to it, every developer's computer had this on it. And what that allows you to do is it allows you to do your own experiments, completely self-contained, to try things out and see what happens, and to really, really go wild and decide whatever you want to do. This caused another problem, though. This caused the problem that if everybody's trying all these experiments, how do you bring them all together again? How do you say Joan is going to try this experiment and John is going to try that experiment? How do we pull things together? And this is where if you hear people talking about Git, you probably hear words like push and pull and merge. And that's really the solutions to these problems, is when you do your experiments on your own machine, and you have to share them, you have to push them to somebody else's machine. Or if you want to see somebody else's experiment, you have to pull their experiment. And that's really all that terminology means. It's just sharing your experiments, sharing your branches. If you push your code to somewhere, you're sharing your experiment. And if you pull their code, you're sharing their experiment. It's just sharing these branches, these experiments back and forth. So here, simply everybody's going, give me everything. So, lag. There we go. So that was kind of very, very basic what Git does. It does a hell of a lot of other things, and I'm not going to go through all of them. If you're a developer, take a note of this slide, and I'm going to point out one thing specifically. This one. If you're a developer, read what that is. That is the best thing Git does, honestly. We have time. I'm going to talk about it. So, Git bisect is awesome. It allows you to find the point in time where something went wrong. Yeah? It allows you to travel backwards in time and go, who screwed something up, when they screwed it up, and how they screwed it up. Best thing ever. Normally it's you that screwed it up, but, you know, or at least that's me. Git bisect. If you're a dev, Google it. Okay, we're starting to run out of time. So, how do I use Git? Let's imagine we're writing a song. Of course, all the best songs are about cheese. No? Just me. So the way we start off when we're talking about Git is we say Git init. Can everybody read that okay? Is that good? Yeah? Awesome. So Git init, that just says to Git, right, we're going to start. We're going to, make this local folder know about Git, or make Git know about this local folder. Then you've got to tell it what files you want to actually know about and what files you want to keep track of. So git add, git commit. So git add tells Git about a file. Git commit, that's where this backup sort of scenario comes in. Git commit takes a copy of the current location and says, right, we're going to snapshot that. We're going to put that to one side, leave it there, and go, we'll come back to it later. Okay, so the best songs are about love, aren't they? So we're going to make that change. I decided I was wrong. It's not about cheese, it's about love. So we're going to make a change. No? Cheese? Cheese? Love? Cheese won. I was right. Cheese? Okay.
Cheese and love are mutually exclusive.
Okay. I don't think everybody heard that, thank God. So you kind of go through this cycle with Git. You do this add and you do this commit. Every time you do this add, you're saying, take my changes. When you do this commit, you're saying, make a backup. And that's kind of what happens here. Every time we do an add, this add commit cycle, we're taking a copy and we're moving it over to the side. So we end up with this history going back in time. It's getting a bit crowded here, so I'm just going to chop that off. Actually, nope, we're going to make a change first. We're going to add a new line in. We're going to chop that off, move that across just so we get a bit more space. So, some other useful things. I've made some changes to my local files, but I haven't put them in this backup. But say I want to know what changes I've made. So diff does that. Diff stands for difference. So we're going to do git diff lyrics. And it's going to tell us exactly what's changed. It's going to tell us that we've added a new line. That's a useful command. But as well as just looking at what the local changes are, we can look at this point in time. We can go backwards. We can look at the past. So we can say, OK, tell me the difference between the current lyrics file and what I started off with right at the beginning in snapshot 1. And it'll tell me those are the changes. It's a little difficult to see what's going on there, and this is another thing for the devs. This is a nice little one. I have another presentation on lots of useful Git stuff, but we're doing this one today. Bad luck. Word diff, best thing ever. Word diff tells you the diff on words. Clever. Thank you. Don't clap me, clap Linus. So rather than showing you that an individual line has changed, it tells you what the words have changed within that. And that's really useful when you've got a scenario where you've got like a dirty long piece of line of code, which you shouldn't do. And then it shows you exactly what's changed rather than just this whole line has changed. The other thing, git log, I showed you this earlier. I just want to go through it a little bit more. This really, really is the point of it. This is where we're getting back to the who, what, and why. Who made the change, why they made it, and when they made it. That's it. So I have another talk which I'm trying to find a home for, which actually goes into the deep details of lots of cool stuff like git bisect and all the fun advanced features of Git. Have a chat with me afterwards if you want to know what some of the stuff are, because there's some snapshots in there that are just awesome. If you know how to use Git, you don't know how to use Git. There's honestly so much out there. That's amazing. Okay, thank you.